Okay, let's get started. It's 1 o'clock. Okay, welcome to our next HDF clinic. It's Tuesday, it's 1 o'clock. I checked our Google document, there weren't any questions. And let's see, I don't see Quincy. Last time I forgot, I'm sure Quincy can answer this question immediately, but I just keep kicking it in the long grass. I will write an example program. It's just I haven't had the nerve. Announcements. Hug is happening. It's starting Tuesday next week, and online registration is still open. Only the in-person attendance is closed. And if you have last-minute ideas, you think you would like to give a presentation or something like that, reach out to the organizers and we'll try to accommodate you. And also these days you should check the program will be posted, and then you can schedule a plan. Of course, with the time zone difference, it might be challenging for some of you, but check it out. And of course there will be recordings in the end, so we'll share those as well. Okay, HDF 110.9 release candidate 1 is available for testing. Just as a reminder, it has the parallel compression improvements that were introduced in 113. They are also in 112.2, but now they are also in 110.9, or they will be released in 110.9. And it also, something as someone who likes documentation, there is also a first attempt at a Doxygen-based user guide. So we have the older version, the HTML versions and PDF versions of the user guide, but we actually started bringing that into the code base, into the Doxygen style documentation. And so look out for that. That's going to be there. And then, for Mac fans, HDF5 is now tested and supported with on the M1 chip. Okay, I'm going to pause here and ask if there are any questions at this point.
No questions.
Yeah. So Quincy is here, so you may ask.
Oh, Quincy is here. Hi, Quincy. Let's see. We had one question that I keep carrying around. I'm too lazy to write an example program. So we talked about hyperslab selections, and when you do set theoretic operations on them, then of course the for the intersection or the difference or whatever, the order of the grid points is of course given by the sort of by the grid point order, the sort of row major in C or the column major order of those grid points. But we weren't sure about when I have a point selection and in which does the point selection also get sort of sorted in grid order first and then sort of processed in terms of the getter or scatter, or is the order adhered to in the case of a point selection?
Point selections are explicitly designed for ordered, to be iterated over, reads and writes, right? When in the order they are defined in the point list. It is an explicit way of getting a particular ordering if you want it, instead of the row major order that the hyperslab or all selections go with.
Okay, thank you very much. Saves me the time to write an example, and then, well, that wouldn't be a proof anyway. It would be one example. But yeah, thanks for clarifying that.
Design. And there's a bunch of tests. They work. So.
Question.
Great. Yeah.
So Quincy, if I use API to return selection, it will not be ordered. It will be in the order I gave it for point selection.
If you request the elements in the point selection back with the get call, yes, it will be in the order they would be iterated in.
And this is different from hyperslab selection that really is ordered.
That has a, you know, as Gerd mentioned, the row major always. Yeah.
Okay, thanks.
Yeah.
Great. Thanks. Okay, switching to the format, to the forum, I'm sorry. There was one posting by someone external. They were saying that they were conducting a survey of self-describing data formats, and they provided a link in here. So it's of course, it's not, I want to point out, this is not coming from the HDF group and so forth, but hey, somebody out there is doing that for their PhD thesis and so forth, and that's great. So I would encourage everybody to participate in this. And the person also, someone asked, they said, yeah, they will share the results once the survey is complete. They will share the results with the community, and so I guess that's a good thing. Then there was a post from someone with some ideas around concurrency, and I didn't have time to sort of think deeply about this, but I'm just sort of parroting some of the responses that I've seen. So the idea that the person put forward was to basically say, or to use the way Python does it. There is this, what people call the global interpreter lock, or GIL in Python. And when they do certain things such as I/O, then the global interpreter lock is actually released, and so that other activities can take place. And then let's say I/O completes on one control flow, but then other activities can proceed on another control flow. And so that person was basically asking, well, couldn't we do something similar in HDF5? And while this is an interesting idea, there might be corner cases where this might indeed work. The devil is, of course, in the detail, as usual here, because maybe in the case of Python, the user level I/O is a much simpler scenario than what happens in HDF5, where you have sort of, we keep talking about this hybrid. If you ask, well, what is the state of the file at any given moment, it is potentially something that is a composite or an aggregate of information that's available in memory and information that's available in storage. And then this, of course, gets much more complicated, rather than saying, yeah, there's a global interpreter lock and it's just user level I/O, and there is not this complex metadata and data entanglement and so forth. But nevertheless, an interesting idea. And I think, yeah, Dana, I think, wrote a pretty detailed response with expressing some of the concerns.
Yeah, I haven't read Dana's response, but I would 100% say, do not do this.
Okay. Yeah, it sounds dangerous.
Well, you know, there's library state, as you said, a hybrid memory plus file state, and just dropping the lock over one piece of the I/O, for example, with a metadata operation, and then trying to reacquire that lock may have mutated the library state in a way that when you pick that lock back up, no longer valid whatever it thought was the state. So it is a, like you said, corner case if it happens to work for you, but it is definitely not a supported direction to go.
Okay, yeah, thanks for the comment.
Sure.
Then there was another interesting post, and here I have to plead ignorance again, unfortunately. But I'm personally not familiar. I've never used FlatHub, but I heard about it. And if you go to the website, it appears to be a kind of a Linux distribution independent or neutral way of packaging software, which is an interesting thing. And here are some applications that are sort of distributed as flat hub applications. I think that's what they are called. And someone was proposing in this thread to say, hey, wouldn't it be great if we could distribute HDF view in this form? And then, so my understanding is FlatHub has some kind of registry where you can register applications and whatnot. And sounds like a good idea. I think there was one response where somebody also was saying, yeah, interesting idea. And then for us, the question would be how, if in any shape or form, we can help that, if it has to do, I don't know. I mean, there must be obviously like building RPMs or building Debian files. There must be some mechanism to package an application such as HDF view as such a FlatHub application. But then, yeah, I think the original poster seemed to be competent and was just checking whether people would find this a useful thing. And I would think, yeah. But then, so stay tuned. Another one, I actually am guilty of starting this thread. This is sort of an idea that's been around for a long time. I know several people who use Visual Studio Code. This is Visual Studio Code, not Visual Studio, not Microsoft Visual Studio, although Microsoft owns Visual Studio Code. This editor that has a fairly well understood and loved way of creating extensions for VSCode, and I think it's typically written in TypeScript or JavaScript. And so people have written nice extensions for, I mean, for the standard sort of scripting type environments, Python, Julia, R, and they seem to be very popular with developers, where you have then a very integrated development experience, for example, where you have, you're looking at your code, then you have a Python shell or Julia shell or something like that, and then you have your project browser open. And it wasn't my idea, but I'm sure in conversation with other people here or users, there was always this idea, well, wouldn't it be nice if we could create a VS Code extension for HDF5, where in HDF view style fashion or any kind of browser style fashion, you would have that on the left-hand side, that tree view where you could see groups and data sets and attributes and whatnot. And so we wanted to use some time at the upcoming Hug event to talk about this, because we will have there the developers from H5 Web, from ESRF, that put together these React components. And so they have a lot of experience with developing sort of TypeScript. And then there is a gentleman from NIST who developed this WebAssembly for HDF5, where you can sort of use the in HTML5, the file system built into a browser to upload an HDF5 file and then use H5 Web to visualize it. And so since we have all the important brains there in one place, I thought that would be the right place to start this. And lo and behold, somebody started already. So someone responded to this thread where we want to sort of collect requirements and ideas, what would we want to get out of this and so forth. But it turns out, yeah, somebody started this already a few months ago, and it's this HDF5 viewer extension for VSCode. So you see that here, that yeah, there is maybe an HDF5 file, and then you can expand that tree view. Of course, I have not had the time to try this, to install this, to see how complete or incomplete it is. But then, of course, complete or incomplete makes sense only with respect to requirements. So, but it's definitely a great start, and I'm sure we'll have a good discussion at Hug about this, and yeah, see how we can, if and how we can improve it. And yeah, so very nice. Any questions, comments so far?
Gerd, just one comment. Does anybody have a direct JavaScript or TypeScript binding for HDF5?
Yes, I believe so. I think there is, I can look it up. So if you look at H5 Web, so there is this H5 Web, right. So here is the GitHub repo. And I think these are just the React components to do the visualization. However, they support multiple backends, including HSDS, but also sort of the native plugin. And I think that gentleman here that developed this WebAssembly, I think he created TypeScript wrappers so creating such a WebAssembly is basically, you take the native HDF5 library and put some JavaScript code around it and then compile it in a specific way for Chrome or for the browser that supports WebAssembly. And so I think one example of such bindings is definitely included in H5 WASM or whatever you want to call this. So that would be one. But then I also know that there were at some point some efforts, I forgot if it was called H5 Node or H5 Node.js or something like that, which was in a similar vein to, in a way, create, if you wish, a server-side component to interact with HDF5 files. But I can do some digging and find out or post this somewhere. But I believe so. Yes, there's definitely one, but there might be multiple incarnations of that.
Yes, and I just was curious. Do they are they able to bind to the entire HDF5C API? Is it really that complete and that sort of thing?
Yeah, probably they are not complete, and there are also two styles. I think one of them, definitely uses the, I don't know what the JavaScript or TypeScript capabilities are to bind to like a shared library or something like that. That's one. But I know one of these Node.js activities really went directly back to the file format. So it was pure JavaScript and did not involve any C. It did not require the HDF5 library. But then, of course, that supported whatever the authors needed, that subset of the file format specification that was relevant to them. But yeah, there were at least two, if not three, such efforts.
Okay, thank you. Interesting.
Okay, then the story continues, and everything very much focused on Hug. Sam from ESRF posted some new performance numbers. So remember, the situation here was that we have this relatively straightforward use case where we record a movie, so to speak. So we have a three-dimensional data set, and we are just writing in sequence, in time order or projection order, as he calls it, frames, images, two-dimensional hyperslabs to this. And we were comparing the performance for direct chunk, where you basically have this three-dimensional data set. That movie, so to speak, is represented as a chunk data set, with time or projection being the slowest dimension, and then the images stacked into that. Not using direct chunk, but using the traditional H5D write with hyperslab selection, but the underlying data set still being chunked, and then compare that with the, let's pretend we know how many time steps we will be recording, how many of these projections, use contiguous layout, and then just do a hyperslab selection and write frame by frame by frame. And here was originally he had posted this number these results for 112.1, and then just to be sure that there wasn't any kind of performance regression with respect to 1.8, he actually posted these numbers for 1.8.22. And the good news is that these numbers are very similar, so there does not appear to be a performance regression. And okay, you could argue and say maybe these 38 seconds here, that's significant, that's sort of compared to these 35, but who knows? I mean, we don't know exactly how loaded the test system is and so forth. But by and large, same ballpark, so there doesn't seem to be any difference. So the mystery in double quotes, or the question really remains, what explains this, let's say, 25% slower performance between direct chunk and writing hyperslabs to a contiguously laid out data set. And yes, we talked about is, okay, there are no data space operations here, sure. But then are these data space operations really that expensive? I don't know, I don't think so. But so at this point, we need to dig deeper. And so, for example, we would create some kind of a profile and then look at the output with one of the cache grind flavors. And that would produce output like this, where we could sort of drill down and understand how the samples are distributed in the code. But of course, that can't replace the looking at the actual code. But then, yeah, we need more of that type of analysis. And then again, we might get a chance on the third day at the Hug event, because Sam will be there and then people from the HDF group will be there. We can spend some quality time and try to dig a little deeper and understand what's going on here. Okay. Unless there are other questions, are there any questions? We'll move to tips and tricks. Questions? No? Okay. Okay, tips, tricks. And that was actually triggered by something I knew, but I just came across sometimes in YouTube history or something like that. Things just pop up. And this is actually something very clever I knew about. And again, right now I'm seeing everything through the prism of the upcoming Hug event. What I can tell you is we will have a couple or more people from the high energy physics community there. There will be someone from CERN. There will be someone from the high energy physics community here in the US. And so we will talk about high energy physics data. And yes, that data typically looks different from maybe some of the data that we are used to, that the people at ESRF, for example, or the people at EDA typically look at. And so one of the data structures or packages that was developed to deal with this high energy physics is often, high energy physics data is often described as event driven data or event oriented data, where you have certain particles reacting, a particle sort of dissipates or splits into other particles, which then in turn split, and each of these splits or fusions is an event. And then you want to, for a given event, you want to know which were the particles that were involved, and then they have certain characteristics like mass, for starters, maybe charge, maybe other quantities. And that data is also the way how it's accessed and processed is maybe different from sort of the traditional dense array structures that we are familiar with. Anyway, here's the list to the project home, but what I really would recommend is Jim Pivorsky, he's up in Chicago. He gave a very nice presentation at SciPy 2020, and that was actually the original video that when I saw that, I thought, wow, very, very clever, very interesting. He's, I believe, the original creator of this awkward array package that he refers to as manipulating JSON-like in the sense of a data structures, these nested objects and dictionaries and lists and whatnot, with NumPy-like idioms. So NumPy-like idioms meaning, yeah, you can do slicing, you can refer to things by component name and things like that. So I highly recommend this video. He starts actually out with a little bit of a description of high energy physics data and so forth, and that is background here. Now, as far as tips and tricks go, you might say, well, how different is that data really that I provided an example here. So how would you, and we'll talk about this in a second, how would you represent data to be described in HDF5? And this is actually an example taken from Jim's video. So when you watch it, I think toward the last third into the movie, he describes how awkward array represents data like this internally. So just to give you a flavor, you can ignore this import statement in this. This is really just there for completeness, and just focus what's in here, which is basically a Python list. So everything in square brackets in Python is a list. So we have a list of lists. We have inside of that outer list, we have 3 other lists. There's one list here. There's another list here, which happens to be the empty list, and then another list down here. So we have a list that contains 3 lists, and then these individual lists are in turn slightly different. So for example, this first list contains 3, call them objects or records, your choice. There is an X field and a Y field, and that X field, at least so far, happens to be scalar, integers for argument's sake, and that Y field turns out to be a list, and at that though a list of variable length. So some of these have 1 element, 2 element, 3 elements, 4 elements. And so the challenge is, if you wanted to represent this type of an aggregate of data structure in HDF5, how would you do that? And the first thing that might come to mind, being in a way fooled or distracted by these components here, you might say, oh yeah, that looks like a compound, like a record. These are fields and so forth. But then if you think about it for a moment, the question is, well, what are you buying? What are you getting yourself into if you went down that path? So that's why I would say, compound, nah. For one, what's going to be a little challenging is, you see already here, there is an empty record. There could also be a partial record where there is only an X component or a Y component. And then, of course, with these guys, sure, you can have a field that is a variable length sequence type. But then if you start thinking about the performance implications and that type of thing, that may convince you to say, maybe there must be a better way. And in his talk, Jim actually describes the columnar layout that awkward array uses internally. And the important thing I want to point out, and if you watch the movie, I think you will get that message, is that awkward array is a package where the data structures, that's one component of it. But the clever part, or the ingenious part of awkward array, is actually to then implement these NumPy style operations on top of these data structures. And that's where a lot of the engineering and cleverness comes from. And again, I refer you to the movie to experience that for yourself. So I don't want to suggest that this is what there is to awkward array. There's a lot more to awkward array, and the sort of the clever ideas are really in the operations on these awkward arrays, not the structures themselves. But here we are talking about, okay, how would I persist something like that in HDF5? And yeah, in HDF5, we would use a columnar layout similarly to awkward array. What we have to do in this case is we would have to pick, like with a JSON object, so to speak, we would have to pick an iteration order in the sense of, do we want to talk about the X fields first and then about the Y fields, or there might be reasons why we might want to care about the Y fields first. So basically we want to iterate in a certain way over these structures, and we have to make a choice in which order we do that. So that's number one. Number two is we just collect, as you would also do with sparse matrices, for example, whether you want to do it row compressed or column compressed or use some of the other approaches. You want to pack the field values into dense arrays. So we would create a value array for the X fields where we just gather 1, 4, 9, and 16 into one array. And then we would gather the values for the Y lists into another dense array. And then, of course, we would have to keep track of, well, okay, so which X values belong to which records, and then also which Y values together form a list, how big are these lists, and so forth. And so you have to basically, if you're familiar with row compressed storage for sparse matrices or something like that, it's the same deal here. So we don't have time to sort of go through this in excruciating detail here. But let's say, for example, for the Y offsets, if we store them as 11, 12, 22, 13, blah, 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 then you can see, well, yeah, the first sequence starts at offset 0 and ends at offset 1. The next sequence starts at offset 1 and ends at offset 3. And then the next begins at offset 3, goes to offset 6, and so forth. So same deal. And then down here, this is a screen capture from Jim's presentation, where he, in a way, describes, I think this captures to me very well, the idea behind having a set of arrays that are then interdependent. And yes, you can literally treat this as, okay, create a group with multiple data sets, or potentially a group and another subgroup or something like that. That's more a matter of taste. But then, yeah, keep track of these offsets and those dense values arrays, and then done. That's and in HDF5, for example, you could have the luxury, and not just in HDF5, in any other system, if you want to maintain for some reason both iteration orders, so either where Y comes first and then X, or X first and then Y, you would just keep more offset arrays and so forth, and that would be all fine. If that's beneficial for your application, then definitely you can do that, of course, at the expense of a certain amount of storage. And so, long story short, the food for thought here is really, sometimes HDF5 is really about finding a balance between what I would call appearance and performance. So if you look at this, does this look very intuitive in the sense, does this look like this, or like a JSON structure like this? And without a little bit of thinking, no, it doesn't. So that's definitely, as far as appearance goes, appearance might be rather confusing, unexpected, non-intuitive, depending on who you ask. But it certainly has performance advantages in terms of storage cost and runtime and so forth. So as so often, it really depends on what you are trying to achieve, depending on how large your data sets are. Of course, this trick here works no matter if you have millions or billions of these records. In a way, the complexity is in the data type alone, not in the actual extent. So whereas if you take this path of a compound type and so forth, then I think you would see performance problems pretty quickly. keeping up. So keep that in mind. And then again, as I said in the beginning, high energy physics data, I think, will be a good topic at the HUG event. And yeah, I invite you to join. And yes, unfortunately, that's all we had time for today. And thanks for coming. And well, I think we will cancel next week's, because of HUG, we will cancel next week's clinic, but then we'll be back the following week. Okay, thanks. Have a great day. Bye.
Bye.